IOLs today not only replace the cataractous lens, but also correct refractive errors of the eye. Monofocal lenses enable patients to see clearly at distance. Patients may select a presbyopia-correcting multifocal lens in order to achieve near vision in addition to distance vision. With multifocal IOLs, each focal point is designed for objects at a certain distance. With multiple focal points, one image is in focus at a time. Now, with the introduction of Tecnis Symfony Extended Range of Vision IOL, a new category of presbyopia-correcting IOLs is available for patients. Tecnis Symfony IOL is the first and only presbyopia-correcting IOL that provides an extended depth of focus, which results in an extended range of continuous, high-quality vision with enhanced image contrast, as well as low levels of visual disturbances. Tecnis Symfony IOL delivers on this promise by utilizing two proprietary complementary enabling technologies, which are the echelette design that extends the depth of focus and the achromatic technology which corrects chromatic aberration. Firstly, let us look at how the echelette design works to extend the depth of focus. Diffractive lens technology and design is well understood in the field of optics, having a wide range of applications, from astronomy to nanotechnology. In ophthalmology, diffractive technology is generally associated with multifocal lenses. However, in the optics world, it is widely known that diffractive technology can be employed to achieve a variety of outcomes, including depth of focus extension. As a matter of fact, light can be distributed in almost any desired way by modifying the echelette design of the diffractive lens. The echelette is the relief or profile of the lens, meaning its height and shape within each ring. The design of the echelette determines how the light is transmitted through the lens. In multifocal IOLs, diffractive technology transmits the light in such a way that it converges at more than one focal point. Tecnis Symfony diffractive lens technology is optimized to transmit light over a range of distances. This is called constructive interference and results in an elongated focus. Because of its elongated focus, the Tecnis Symfony IOL delivers high-quality vision through 1.5 diopters of defocus and an increase of 1 diopter range of vision throughout the defocus curve compared to a monofocal IOL. The plateau of the defocus curve demonstrates the extended range of vision of the Tecnis Symfony lens. In addition, because of the elongated focus, the Tecnis Symfony IOL does not have the distinct focal points of a multifocal IOL, and as such does not have the distinct out-of-focus images that can lead to halo and glare. As a result, the incidence of nighttime halos and glare is low. Now let us look at how the achromatic technology works to correct chromatic aberration. Visible light is composed of a range of wavelengths that are red at one extreme and blue at the other. The cornea of the natural eye is a refractive lens, which is more powerful for blue light than red. The eye can only be in focus for one wavelength at a time. As such, the remaining wavelengths of visible light, which are out of focus, cause blur and a reduction in contrast vision. This is called chromatic aberration. Chromatic aberration can be reduced with a diffractive IOL because a diffractive lens is opposite to the cornea in that it is more powerful for red light and less powerful for blue. The effect is that the wavelengths of color meet at the same focal point, so that blur and aberrations are reduced. But achromatic technology applies this principle to not only reduce chromatic aberration, but to correct the chromatic aberration of the natural eye. This is similar to examples in the photographic world, where refractive and diffractive lenses are also combined to correct chromatic aberration. Correction of chromatic aberration results in a sharper focus of light and increased image contrast, which is especially important in low light conditions. The Tecnis Symfony IOL is the first and only presbyopia-correcting IOL that provides an extended depth of focus, which results in an extended range of continuous high-quality vision with enhanced image contrast, as well as low levels of visual disturbances. In addition, the Tecnis Symfony Toric extended range of vision lens provides all the benefits of Tecnis Symfony IOL technology for patients with astigmatism. Indications and important safety information for Tecnis Symfony and Tecnis Symfony Toric IOLs. RX only. Indications for use. The Tecnis Symfony IOL model ZXR00 is indicated for primary implantation for the visual correction of aphakia in adult patients with less than 1 diopter of pre-existing corneal astigmatism in whom a cataractous lens has been removed. The lens mitigates the effects of presbyopia by providing an extended depth of focus. Compared to an aspheric monofocal IOL, the lens provides improved intermediate and near visual acuity while maintaining comparable distance visual acuity. The model ZXR00 IOL is intended for capsular bag placement only. The Tecnis Symfony Toric IOLs, model ZXT150, ZXT225, ZXT300 and ZXT375 are indicated for primary implantation for the visual correction of aphakia and for reduction of residual refractive astigmatism in adult patients with greater than or equal to 1 diopter of preoperative corneal astigmatism in whom a cataractous lens has been removed. The lens mitigates the effects of presbyopia by providing an extended depth of focus. Compared to an aspheric monofocal IOL, the lens provides improved intermediate and near visual acuity while maintaining comparable distance visual acuity. The model series ZXT IOLs are intended for capsular bag placement only. Warnings: Tecnis Symfony IOLs may cause a reduction in contrast sensitivity under certain conditions compared to an aspheric monofocal IOL. Inform patients to exercise special caution when driving at night or in poor visibility conditions. Some visual effects may be expected due to the lens design, including perception of halos, glare, or starbursts around lights under nighttime conditions. These will be bothersome or very bothersome in some people, particularly in low illumination conditions, and on rare occasions may be significant enough that the patient may request removal of the IOL. Rotation of the Tecnis Symfony Toric IOLs away from their intended axis can reduce their astigmatic correction, and misalignment greater than 30 degrees may increase postoperative refractive cylinder. If necessary, lens repositioning should occur as early as possible prior to lens encapsulation. Attention! Reference the directions for use for a complete listing of indications and important safety information.